This is a curve sketching form activity, and I want to go through the whole thing so that hopefully this will help you in doing yours. So we start with any function, and we're going to put that function right here in the function line. The first thing you want to do is find the first derivative and the second derivative. And of course, the first derivative is going to be 4x cubed minus 12x squared. And the second derivative from there is going to be 12x squared minus 24x. All right, from that point, we want to be able to fill in our critical numbers here, which comes from setting the first derivative equal to 0, and the point of inflection here, which comes from setting the second derivative. So if I come over here, f prime of x, and I'm going to do 4x cubed minus 12x squared equals 0. I'm going to factor out 4x squared. And that leaves me x minus 3. So this is going to set that equal to 0, and this will set that equal to 0. So we get x is equal to 0, x is equal to 3. Now those are my critical numbers, so I'm going to put them here on this line. I do the same thing for the second derivative, and that's going to be 12x squared minus 24x equals 0. And I'll factor out again. I'm going to take out a 12x, which leaves x minus 2. All right, and that's going to be equal to 0, and that means I'm going to have x is 0 here, and x is 2 here. All right, so let's write those over here, and we'll notice that we're getting x is 0 as a critical number and as a point of inflection. All right, so the first thing we want to do is go down to our, we'll just get a spot down here, and we're going to draw a bar and put those numbers on here. And we want to put them in order. We had x equals 0, and we had it twice, but we're just going to put it once in our bar. X equals 2, and x equals 3. Then we want to define these intervals. Remember, we have to go to positive infinity, and we start at negative infinity. So here is 3 to infinity. This is 2 to 3. This is 0 to 2. And this is negative infinity to 2. All right. All right, we are going to put all of that information up in our chart. So if we go up here, we want to start with this left. Let me see if I can get both. So we want to put this interval first. So we have negative infinity to 2. Then next comes, that is not to 2. Goodness gracious. Negative infinity to 0. I just wrote that wrong right there. Negative infinity to 0. Okay. So, and then we have x equals 0. That's going to come here. All right, our next interval is 0 to 2. Then we have x equals 2. Then we have an interval from 2 to 3. Then we have x equals 3 as we go down the bar. And then our last interval is 3 to infinity. All right, so we created the chart like we've been doing, and we just put it vertically this way. All right, now down here, we want to pick some test points in those intervals. So here might be negative 1, and this might be 1, 2.5, and 4. Okay. And then we're going to, excuse me, we're going to test those points in f prime, well, let's call it y prime. We're going to test it in y prime and y double prime. That means you're going to take all these four numbers and plug them in to y prime and y double prime. And you're looking to see, am I going to get a positive or a negative number? All right, the test points that we used had to fall in here, in between these two numbers. Okay, so when you do that, I'm assuming you will do that work, we will end up getting those for the first derivative, and then we'll get this for the second derivative. Okay, now we're going to transpose that up to our chart, and this row is going to become this column here, and we'll put it where the intervals are. So we had a minus, a minus, a minus, and a plus. And we're putting it for those intervals that we had. And for y double prime, we had plus, minus, plus, plus. So we simply took what we found down here and we transposed it vertically to here. Okay? All right. Now, you have a y column. That should get filled in across from these 3 points. You're going to take these 3 and plug into y, which is your original function. So you're going to put 0 in here, and obviously you would get 0. When you plug in 2, you're going to get negative 16. When you plug in 3, you're going to get negative 27. All right, we now have everything we need to write our conclusions. And remember that y prime talks about increase or decrease, and y double prime talks about concavity. So in this interval, we are decreasing and we are concave up. In this interval, we are decreasing and we are concave down. In this interval, we are decreasing, concave up. And in this interval, we are increasing and concave up. All right, now we also need to get a conclusion about the points. And at 0, 0, let's look here. On either side of 0, we did not change from negative to positive or vice versa. So this is merely a point of inflection, which we found right there. And then at x equals 2, that was the same thing. That was a point of inflection. At x equals 3, to the left of it, we are decreasing. To the right of it, we are increasing. So what does that mean we're left with? We're left with a min. So this is a min at 3, negative 27. All right. So now we should have enough information to sketch our graph. So we're going to go down here, see if we can have our chart here. Let me make this a little bit bigger. Move it over here a little bit. Okay, so we'll come down. Okay, so what you first want to do is plot the 3 points that you've got. Now, obviously, your graph unless you were on a full sheet of graph paper, you might not have these, the y depth to get these. So we'll draw it on here. So we've got 0, 0, and then we need 2, and down here at, say, negative 16, and we don't know exactly where that's going to be. I'm just going to label it so that we know that's what it's supposed to be. And then we had 3, negative 27, so I'm going to be down here, and I'm going to call that 3, negative 27. Okay? Now, we want to look at the chart. I'm going to make it smaller so we can see the chart and the graph. And we want to think about what's happening. So from negative infinity up to 0, it is decreasing, but it's concave up. So it's kind of doing that. All right, I don't want to draw it yet. And then from 0 to 2, right in here, it's decreasing and concave down. And then from 2 to 3, it's decreasing and concave up. So it's going to kind of make it's coming down, but it's going to make a little curve. And then we hit this min, and then from then on, it's increasing and concave up. So let's see if we can do this. We're decreasing, but we're concave up. And then we're decreasing and we're concave down. And then we hit that min and we go up like that. So that kind of looks like what I think it should be. If we go to our calculator, so if we grab our calculator and we put in x to the 4th minus 4x cubed, and I hit graph, I get something very similar to what I sketched here. Now, if you don't see it right away completely, just remember you may change your window. I changed mine to a y min of negative 35. So again, we were pretty accurate just using our calculus, our derivatives, and that really gave us the whole big picture. Let's see if we can get that all on there. So hopefully that will help you get started on that, or just a review on that, whichever you need.